Let's talk about building a quadratic equation if I give you the x-intercepts and one additional point that's on the graph that it relates to. So here's my basic function, quadratic function, ax squared plus bx plus c. And we know that the solutions, when you set f of x equal to 0, represent the x-intercepts. So what that means is if you're given this function and I ask you to find the x-intercepts, all you have to do is set this equal to 0 and solve, which you guys should all be experts at by now, right? We're just going to factor this, set it equal to 0, and then each of these, using our zero product property, right, have the potential of being 0. That means that our x-intercepts are going to be 3 and -2. Okay, well that was easy. So let's talk about the x-intercept form of a quadratic equation. So what we have up here, this is the standard form. So now we're going to talk about the x-intercept form, or the intercept form. And that looks like this, where you have a times, and then we have two binomials here, x minus x1 and x minus x2, where x1 and x2 are the x-intercepts. Okay, so if we go back up here, the x-intercept form of this would be f of x is equal to a is 1, and then we have x minus 3 and x plus 2. So if it's in that form, it makes it really easy to just read off what your x-intercepts are. And also you can take a look at A to help you out understanding if it's opening up or opening down, how stretched or compressed your graph actually is. And I know in this case up here, A was 1, but you can think if I had actually multiplied all of this through by, say, 3, and this would be 3x squared minus 3x minus 18, before you factored anything like this, you would actually factor out that GCF of 3. And so there would be a 3 hanging out in front here. And so 3 would have been A. All right, so just don't assume that A is always going to be 1, which is very easy to do. So what are the steps that we're going to take to build a quadratic function from our x-intercepts? Well, the first thing you're going to do, if you have your x-intercepts, you're going to place them, those values, in for x1 and x2, knowing that there's still an a here that we don't know yet. Now they're going to give you this third number. This is an extra point that's actually on the graph. So something like 5, 1. And you're going to take that value of 5 and 1 and plug it into this equation that you just started to build with the x-intercepts. So the x, the 5 that I had, would go here and here, and the 1, which is the y, would go there. And once you've plugged all that in, you should have enough information there to solve for a. And once you have a, the third step is to substitute a back into this original equation, and then you just multiply it out, and you've got your quadratic function. Seems easy enough, yeah? So let's try it. So these are the 3 points that I'm giving you, and notice that 2 of these are the x-intercepts. So here's one x-intercept, and here's the other one. And this 4, 3 is that third point, or point that's on the graph that it passes through. Okay, so step 1 was to create our equation by plugging in the x-intercepts. So remember, the x-intercepts are going here for x1 and x2, and you're always subtracting them. So if it's x minus a -2, that becomes x plus 2, and then x minus 5. Now remember, don't forget the a. You're not done at this point. You don't just multiply these out and say you're good to go. We actually have to figure out what a is. So the next step is to take this ordered pair here, 4 and 3, and replace this x and that x with 4, and replace that y with 3. So once we do that, 4 plus 2 is 6, and then 4 minus 5 is -1. We can simplify this. Isolate a, divide through by -6, and so a is -1/2. So you're almost done, because now step 3 here, it says substitute a into the equation from step 1 and multiply it out. So this number goes right there, keeping the x plus 2 and the x minus 5. And then you multiply it out. So now we can distribute or FOIL, and then distribute the -1/2, and we get our function. Okay, so there you have it.